Hello and welcome. Today we are going to use this capacitive sensor as a binary digital input. This capacitive sensor works like the push buttons, but in this case this is just a touch sensor. It's somehow like the technology used on your cell phone, on the screen in your cell phone. So you just need to touch this element. There is no mechanical interaction, and then this is an advantage because after some time when you push over and over and over this little guy, because it is a mechanical button, it wears off. So we got this touch sensor, there is no mechanical interaction, so it's an improvement. Then for this circuit we need 3 push buttons because we are going to use the 3 push buttons along with the capacitive sensor in order to get like something like a password. I need to press, or I need to select some specific combination on my buttons and my capacitive sensor to provide the signal in my LED and turn it on. So of course I need my Arduino board, we know this, and we need 4 resistances. The value is 330 ohms resistances, and we use this, remember, to ensure the zero logics in the buttons. I explained this phenomena previously. So I need 3 resistance to ensure 0 logics on my buttons, and I need an extra resistance for my LED. So let's get started. First of all, I need to insert the buttons on my breadboard. So all I need to do is to get this little guy and put them inside of my on the holes of the breadboard. You see, like this. I just need to push and then it gets in. I am going to do exactly the same on this button and finally on this button, and that's it. Now I got my 3 buttons in my breadboard. Next I'm going to introduce the headers. These like needles elements are the connection terminals, and we call them headers, and we use to provide connection to the sensor. So all we need to do is to put the headers inside of these little holes, exactly the same as we did with the buttons. So just push and that's it. And look carefully, it has some text on it. It says SIG for signal, VCC for positive power supply, and GND. So we are going to provide these connections. The last one, the left one, GND, requires a negative connection. So I'm going to use the black wire to connect the signal, the GND, sorry, line. Look, here I got my GND connection. If you look, this is GND, and this GND connector goes in this little hole. Then the GND connection has electrical connection with any hole, any connector in this whole line. So I get negative from the blue connection, and I provide connector here, and it could be on any hole, any connector in the same line, this in this manner. Do you remember the internal constitution of the breadboard? It has metallical elements providing electrical connection in the same line. So exactly the same. In the middle says PCC, that stands for positive connection, and then all I need to do is to provide positive connection. So I put the wires inside. Give me a second, I need to move this like this, and that's it. So now, as you can see, the middle leg, the VCC leg, is connected to the red line, because I'm going to use this whole red line to provide positive connection. And finally, the signal connection provides the signal of the sensor. So I'm going to send this connection into a digital port in my Arduino board. I'm not going to do it right now because I need to show you the program. Now, let's continue with the buttons. Remember, the buttons are used to produce, or actually to provide, a binary digital signal that is 0 volts or 5 volts. So in one side of my button I need to provide positive connection. So I'm going to connect this leg. This one goes to positive. You see? This one goes to positive. In the middle I got nothing, and then in this part of my button, when I press my button, I get the signal. I got 5 volts, gets here, and nothing happens because the circuit is open. If I push my button, the circuit closes, and then I got my signal from this leg to this leg. Remember, I need to be sure that I got a 0 signal when I don't press my button. If you remember, that's why I need to use this ground resistance from ground to the signal terminal in order to ensure the 0 signal. You see, this leg is connected in the blue line, and this one is connected in the same line with the second leg of my button. I'm going to do exactly the same with every single button here, like this and like this. I'm just providing positive power to my buttons. Okay, I need to do it carefully. There it is. I got my positive connections for every single button. This is the positive connection for this button. This is the positive connection for this button. And now I need to do exactly the same in the secondary leg. The signal leg, I need to use the resistance to ensure a 0 digital signal. I explained this phenomena. There should be a video on my channel so you can check this phenomena and the explanation for this. And that's it. Now I need to connect my LED because I'm going to turn this LED on when I press the proper combination. So remember, the LED has two legs, a short one and a long one. If you see carefully, the one, okay, there it is, the one in the right side, this one, it's longer than this one. So the long one is positive and the short one is negative. That is only for brand new LEDs. If you trim these legs, you are going to be in troubles because there is no way for you to identify the positive or the negative. Actually, it is possible. If you look carefully, it may be difficult here in the camera. Let me try to change the focus. Maybe I can get a better image. Okay, but it's hard to identify the flat side. Here I got a flat face and here I got a round one. Yeah, it's really difficult. Okay, maybe there it is. You see, here is flat. It may be difficult. Maybe in the real one, there it is flat, and in this side it's round. It's difficult to show it in the camera, but maybe if you got the real one, you may be able to identify this. So, flat or short leg, it's negative, and long leg is positive. So the long one is this one, so I'm going to connect it like this, and this one, it's the short one. Remember, let me show it again. You see, this is the short one, this is the short one, so it goes to negative, and we use this resistance to provide the negative connection. You see, in the same line I got the short leg and the leg of my resistance, and the second leg of my resistance goes connected in the blue line. That's it. That's all I need for my circuit. Now I need to provide the connection from my Arduino card to my circuits. For that, let me show you the program I need to use. I got button number 1 identified as port number 1, button number 2 for port number 2, 343, 444, and the LED should be connected into my port 0 in the Arduino board. So let's go back to my circuit, and I want to use this order. This is going to be button 1, 2, 3, and 4. I can change that order. Yes, I can, but I don't need it. So this is the LED. Remember, the LED should be on port 0. So I'm going to use the orange connector in my port 0 like this. That it is port 0 orange, and the second side of my orange goes to the longer leg of my LED, like this. You see, in one leg I got the resistance, in the positive I got the signal from my Arduino board. Now I need to provide connection to the buttons. So I said this is my button number 1. So from the leg with the resistance, I'm using the white connector. I put it in the same connection with the resistance. You see, here is my resistance, here is my jumper in the same line. So I need to put the white connector in the port number 1. I need to be careful not to mix the connections. That it is. The white one goes to button number to port number 1. Now purple goes to number 2, and purple goes to my second button. You don't need to follow the color of my wires, okay? I use the colors just to show you that purple goes to port number 2 and purple goes to my button number 2. So I use the colors only to show you how this works, but you don't need to use exactly the same colors. So I'm using again orange, and orange goes to the button number 3, and I use it on port number 3. And there it is. And finally, the signal from my touch sensor goes in the port number 4 of my breadboard. There it is. It's brown, port number 4, and brown in the signal port of my touch sensor. Now I am going to send the program into my Arduino board. Look, I need to provide power to my circuit. I am not using this because I want to send the program first to the Arduino board, and after that I'm going to provide power. If I connect the power and transfer the program, there is a high chance for us to get an error message. Check my channel, there should be a video explaining this error. So I plug the USB port. Let me show you my program. This is my program. Look, according to my program, I'm going to turn the LED on. Okay, it's not visible because, let me move it. It's not visible because I got the breadboard. Okay, let me remove the breadboard. There it is. So I'm going to turn my LED on when I press button 1, 2 and 4 all together. Okay, I need to press 3 of them together. You will see I can press them separately and the LED is not going to turn on. The LED only is going to turn on when I press button 1, 2 and 4 together. So let me show you the breadboard again because I want you to see the transfer behavior of the Arduino. So I got my program. Remember, I need to choose the proper port that says Arduino Uno. This time it's COM number 6. I need to be sure that I choose Arduino One board, and if everything is okay, I may be ready to upload the program. I need to press this, and then I got this message, this bar, the LED turns on. Don't worry, it's not a problem. And when I got, let me go back to this. When I got this message, done uploading, and in Spanish it's subido, it depends on your language, you got your program in your Arduino board. So let me go back to the Arduino board because now I need to provide power to my circuit. So I connect my red connection. Remember, I like using colors to make this easier for you, but you don't need to use exactly these colors, it's not important. So I need to provide 5 volts to the positive. So in the upper side of the Arduino board, it's hard for me to show you. Okay, maybe like this. The light is not so good. Okay, I'm going to show you a drawing of the Arduino board. Here it is. So here I got 5 volts and GND. Here in the real card I got exactly the same layout. Unfortunately, light is not so good, so I cannot show you, but look, I'm going to connect the red one from 5 volts to the red line in the breadboard, and the GND connection with black to the blue line in the breadboard. So let's go back to my circuit and let me connect the 5 volts connector. It's the number 4, so 1, 2, 3, 4, that's it. And here it is, from 5 volts to the red line, there it is, and GND to the blue one. So that's it. And as you can see, when I put power on my circuit, the LED on my capacitive sensor turns on. So I put it and it turns on. That means that my connections seems to be correct. Now let's check the circuit. If you remember, the program says I need to press button 1, 2 and 4 together. So let me press button 3 and nothing happens. Button 2 and 3, nothing happens. 1 and 2, nothing happens. 1 and 3, nothing happens. I press only the capacitive, nothing happens. And you can try any combination and nothing should work. All together, 1, 2 and 4 together, and there it is. You see? That's the way it works. Well, I hope this is useful for you, and see you the next time.